Hello, my name is Lieutenant Commander Jacob Cole, and I will be talking today about some use cases of virtual reality in medical education. I'll be focusing a little bit more today on the equipment that is used to provide an immersive virtual reality experience and hope to provide some perspective on this emerging technology and how it will likely be implemented into simulation education in the coming years. My hope with this presentation is to provide a broad overview of what virtual reality is and then dive pretty specifically into what is currently available off the shelf and how it is being used in healthcare education. I'll talk a little bit about the major domains that it's currently being used in medical education, and then talk a little bit about the limitations that you might experience if you try to implement this in your simulation center moving forward. And then I'll talk just briefly about the development process and how you can move forward and develop your own simulations in virtual reality and how you can use this technology to provide that type of simulation education in the future. But before we talk about that specifically, I'd like to touch briefly on Everett Rogers and his innovation curve. If you're not familiar with this, you've likely heard about it at some point, and depending on who you talk to, it describes the phases of adoption of an emerging or a disruptive technology. As we talk about virtual reality, it's important to realize that this truly is an emerging technology. Most of the major innovations at the commercial level have occurred in the last 5 years. And even the most forward-leaning sim centers really can only be considered early adopters at this point. Now, virtual reality in this educational domain is still something of a solution looking for a problem, to be honest. Those innovators who have published early studies demonstrating its non-inferiority to traditional methods of education, well, they were often met with skepticism and some frustration. There was a lot of resistance to this idea of virtual reality education. Unfortunately, Everett Rogers would tell us that this response to an emerging technology is to be expected. Now, in the coming years, however, as use cases of virtual reality start to diffuse into the domain of healthcare simulation, implementation of virtual reality will likely become easier as some of these initial resistances may be overcome following its widespread adoption. Now, what actually is virtual reality? And it's important to actually define what virtual reality is, because many people may consider virtual reality to be pretty much any technology along this spectrum that is described by the extended reality continuum. New technologies have emerged that talk about augmented reality and provide augmented reality, which means overlaying data onto real planes and real surfaces in the real world using either a smartphone or a head-mounted display. Virtual reality, as we're going to talk about it in this presentation, describes immersive virtual reality, where the user is placed within a simulated environment and has really first-person perspective within that environment and the ability to move around and interact with the environment from that perspective, and sees nothing of the real environment while they're there. There are some standard definitions for these different technologies along the extended reality spectrum. In augmented reality, it does describe the superimposition of digital data onto objects in reality. Meaning, if I look at a wall, I can put a web page on that wall. If I look at a sign, it can read that sign for me and navigate to something indicated on that sign. Virtual reality describes, in general, a first-person perspective within a virtual environment. And then when the user is within that virtual environment, they interact with it in real time using either their hands or a controller of some sort. And while they're in that virtual reality space, they are entirely immersed in that environment, meaning all visual, auditory, and in most cases haptic feedback from the real space outside of the virtual space is blocked away, and the user is immersed in this virtual reality environment. Now, for simplicity in this talk, I'm going to use a few different terms. If I say VR, I'm talking about virtual reality. AR, we'll briefly talk about augmented reality. If I mention an avatar, that is a virtual representation of the user within the virtual space. So we can talk about the hands of the avatar being used as a means to interface with the simulated model that the virtual environment provides. And then SPs, or standardized patients, is relatively ubiquitous throughout simulation education, and I'll be talking a little bit about them throughout the course of this talk as well. So why is this an emerging technology? Why has this only come about in the last 5 years or so? And the reason is the technology is really only miniaturized to the point that it can become relatively commercially available, and that developers are able to have the potential to distribute this to the masses. Previously, prior to that, the technology was too expensive for real commercial distribution, widespread commercial distribution, and there was no impetus for developers to put time and energy into developing things that only a handful of users with incredibly expensive headsets would be able to use. So now, as that commercial technology has gotten to the point that it is widely available, the fact that the screens within these devices have gotten to the point that they can have such high resolution and high refresh rates so that they minimize on kind of motion sickness while a user is using it. The displays are able to be miniaturized to the point that each eye has its own display and can provide 3D imaging. One big innovation that occurred in virtual reality was the movement from outside in motion tracking to inside out, meaning that the headset itself monitors and measures movement as opposed to relying on external sensors following either reference points on the headset itself or on the user themselves. And this allows for a very compact and streamlined device that really is just a headset that the user can wear in order to experience the virtual reality environment. Additionally, the idea of haptic feedback, or actually feeling something in virtual space, has come a long way, and the different controllers that are used are much more capable of providing that high fidelity haptic feedback than they were in previous years. And they're really getting to a point where it's pretty astounding the level of fidelity that they're able to provide. The one thing that is very interesting that this individual in this picture here may be demonstrating is these human-based user interfaces. So doing away entirely with a controller and simply using the patient's own hands tracked by cameras on the headset to meaningfully interact with a simulated environment. By removing the controller, it just increases immersion into that environment and makes the user feel like they are actually out of real space and truly within this virtual space. And the last thing that has provided some really profound immersion into the simulated environment is these 3D spatial headphones, blocking out sound from the outside real world and immersing the user within that virtual space. All of these things have come together, now been miniaturized, now been gotten to the point where commercial production of them is no longer cost prohibitive, and they've been put together into these headsets that range in cost from a few hundred to just maybe a little over $1,000 for a comprehensive virtual reality experience. And this diagram just provides a brief overview of the main, I guess, differentiation points broadly in the different types of virtual reality devices that currently exist. Now, in 2016, HTC released their Oculus Rift and their Vive headsets, seen here and here respectively. These are both tethered headsets, meaning that they have to plug into a computer, and then that computer actually does all the graphics processing and feeds that video output data to the headset. And there's benefits to that in that generally you can provide a higher fidelity experience with greater graphic resolution. However, there is a tether that connects the user to a computer. But initial technologies absolutely required that. And since that time, as processing power has become, again, miniaturized and optimized, we have seen that certain technologies, such as, say, the Oculus Quest 2 up here, no longer requires tethering to a computer and can still provide that high fidelity education without the need for an expensive, essentially gaming computer at that point. Also, one thing to mention is the motion tracking. Previously, there was a need for an external motion sensor that actually detected reference points on the headset. Nowadays, almost all headsets utilize an inside-out tracking system where the headset provides all the telemetry data, then all the movement data and motion data that it feeds back into either the computer it's tethered to or the processor within the headset itself. And then certain headsets also provide a see-through capability. Most headsets have some type of camera on them to provide reference to the ground and the environment around them. So it's just one other a factor to look into when you're comparing these different models. All right, so I included this slide here to give you an example of what a sim center of the future could look like. I think anyone who's worked in a healthcare education sim center has the image in their mind of mannequins stacked up to the ceiling with highly specialized task trainers that just take up room and need their own dedicated spaces in many cases. Virtual reality provides the opportunity for a relatively low-cost headset and software to provide a relatively high-fidelity education with very little need for dedicated space within a sim center. You can see here this is a gaming studio. It's a combination bar gaming studio that provides virtual reality experiences, and you can imagine a sim center of the future could look very similar to this without the need for costly mannequins with all their upkeep and otherwise. I thought it was just a very interesting picture and kind of gives a little snapshot of what the future could be. And then to get us there, one of the most important things that you need in order to experience virtual reality is obviously a virtual reality headset or a virtual reality system. So these are the, I suppose, major commercially available virtual reality devices that are on the market right now. There are others out there. These are just ones that I included that I'm familiar with that are relatively well used in the industry and kind of prolific. So we'll start with the Valve Index. This is it's a headset system that has a relatively innovative input device with the controllers that have very profound finger tracking. So you can actually, you use a handset and you actually use, you manipulate the handset similar to what the individual in the picture here is doing. However, you're able to move your fingers and it tracks all of that. So it gives you a lot of dexterity when you're in the virtual environment. The HTC Vive Pro 2 probably is the highest resolution and most graphically intense and graphically pleasing virtual reality headset that is available today. Both of these, the Valve Index and the HTC Vive Pro, are tethered, so they require a gaming computer to provide them with a video signal. So that actually just, it increases the cost. So each one of these would need a dedicated computer in addition to it. The Vive Pro 2 can have an optional wireless tracker. It just decreases the quality of the image that it's able to produce. And then the Facebook company, I suppose Meta now, put out, owns Oculus and made both the Oculus Rift S and the Meta Quest 2, used to be the Oculus Quest 2. Of these two, I'll talk briefly about the Meta Quest 2 because it is probably the mainstay for non-tethered standalone virtual reality devices that are commercially available right now. It has very reasonable resolution with a relatively wide field of view, and it's entirely untethered, and it is able to provide through some video cameras that are implanted or that are incorporated into the headset hand recognition, which again, as I mentioned before, is one of the things that can really immerse a user into a virtual environment where they don't need to use the handsets. They can just use their own hands in the environment as if they would naturally, really increasing that immersion. Now that we have talked about what virtual reality is and a little bit about what you would need in order to implement it within your sim center, I want to talk about why you would even think about implementing this into simulation education. Like, what is worth the headache of trying to implement an emerging technology without established benefit for education? Well, when you sit back and think about what virtual reality is and what it could bring to the table, it's hard to argue with its potential to improve the domain of simulation education. And really, probably the biggest aspect of this is its portability, its accessibility, its ability to provide on-demand education. You can imagine sending a learner home with a headset, and with that headset, they are able to engage in simulation educational activities that would previously have required a sim tech, a proctor, a standardized patient, specialized equipment, mannequins, set up and run. By virtualizing all of that into a computer program that is repeatable, that can provide rapid feedback, this type of portability and accessibility is really unheard of, and it has the potential to really revolutionize simulation education as we know it today. Despite its kind of nascent and early nature, virtual reality has been shown to improve understanding of 3D anatomic structures. It's also been shown to provide some improved learner immersion within simulated experiences. It's always been, at least a feedback from my experience, and it's documented in the literature as well, to learners who engage in simulation experiences that say, oh, it's just not real enough, or oh, I just didn't feel like this one thing happened and it was jarring and it pulled me out of the simulation. I didn't feel like it was real. Virtual reality has the potential to fully immerse the learner in that environment, which just improves the quality of the simulation experience as a whole. So from here, we'll talk a little bit about some of the different use cases, specifically where virtual reality has been shown to provide some benefit. Now, the first use case we're going to talk about is virtual standardized patients. So what is this? What's a virtual standardized patient? Standardized patients take training, they interact with the learners. Well, a virtual standardized patient is really just that. It's a standardized patient that is run as a computer model within a virtual simulated environment. And due to advances in artificial intelligence, deep learning technologies, natural language processing, speech to text, learners are able to verbalize, talk to these computer models, and the models are able to respond eloquently. They're able to respond meaningfully. They're able to respond in a way that allows the learner to make diagnoses and interact with them and practice some of the non-technical skills, some of the communication type skills, some of the empathy type skills. And there is a reasonable body of data that's being amassed using these virtual standardized patients. I've included a few different references at the end of this presentation that show that this is relatively effective. And in addition to being effective in providing that training, one of the things that's really interesting about virtual standardized patients is its ability to provide immediate feedback to the learner based upon their actions. Now, typical standardized patient encounters will have a proctor that sits outside the room, either virtually or through a one-way mirror, and watches the interaction between the learner and the standardized patient. In a virtual standardized patient encounter, the model is able to recognize different actions that are performed by the learner within the virtual space, and is able to recognize when certain questions were asked, when certain physical exam findings were elicited, and provide feedback to the learner based upon a preset list of learning objectives that need to be met. This allows the learner to get immediate feedback, not only after running through the scenario, but also running through the scenario again and again. These scenarios are repeatable. The learner can reiterate as many of them as they want in order to attain some degree of mastery that they're just really not able to with a standardized patient encounter. Those encounters tend to be a one-off. The learner goes in and they have an encounter and then they leave. This provides repeatable encounters that can be performed using these standalone VR headsets that you might send a learner home with. So at home, they can practice, they can log, they can incorporate it into an educational curriculum, these different encounters, and the proctors can then log in and see how they did based upon the feedback that was provided to the learner immediately after their encounter. A lot of this came out in necessity during the COVID-19 pandemic, where a lot of face-to-face instruction was hampered, was canceled, honestly. And we're seeing now, kind of in the wake of that pandemic, that there was a reasonably high fidelity training that was still occurring despite a lack of standardized patient encounters. And these virtual standardized patients, as artificial intelligence and speech-to-text type natural language processing algorithms tend to improve, will only kind of improve their fidelity and may potentially in the future serve to supplant some of the standardized patient encounters, if not supplant, at least augment the SPs that we have today. And this is just a slide of a learner going through a virtual standardized patient encounter. You can see, in this case, a real-time proctor seeing what the learner is seeing, and she's using a standalone headset that is not tethered to any computer system. This is something that the learner could take home with them and engage in these activities at home. You can see that the learner is examining a patient within a hospital room. You can see the telemetry, you can see the patient interacting with them, looking at them, following them, talking to them throughout the encounter here. This is just an example of the type of experience that can be provided by these type of technologies. Now, another use case that is pretty prolific in virtual reality is anatomy training. Anyone who has been through medical school or certain types of medical education will never forget their cadaveric anatomy training. But this is just incredibly expensive for institutions, and over the last 2 decades or so, the amount of time spent in the cadaver lab learning anatomy has just slowly decreased, and it's starting to be supplanted by 3D models that, I mean, I went through medical school in 2012 when we were doing our cadaveric dissections, and at that time we had apps that you could bring up on your iPad or your iPhone that you could take away layers of tissue and examine the anatomic structures underlying them. Today you have virtual reality, which allows you to get in, move around, interact, as you can see here, using your hands, and manipulate the tissue in a similar fashion as to what you would see potentially during surgery, removing tissue planes, dissecting, and seeing where the different anatomic structures lie, coarse, and otherwise are within the body. This has been, of the different domains where within education where virtual reality has been looked at and investigated, it's been relatively well studied, and what we've seen is that these virtual reality with these 3D anatomic models are not inferior at worst to traditional cadavers. If not, certain studies have shown that they provide better immersion with some better memory recall to students than a traditional cadaveric model. Certain students, and this generation of students that would be undergoing this type of training, may just respond better to a more video game type educational environment compared to the dour, drab, and sometimes emotionally conflicted experience that is dissecting a cadaver. The other thing that this provides in a much more cost-effective manner than traditional cadaveric dissection is improved access. Again, a learner given this headset could take it home and dissect a cadaver as often as they like at home in a virtual environment. Some of the more modern 3D anatomic training softwares, virtual reality experiences, virtual reality suites incorporate a lot of real anatomy and real anatomic scans and slices to augment kind of the virtual models, the 3D models that are provided kind of as standard with the software itself. So overall, this is a technology that I do believe will, in the next few years, largely supplant a lot of cadaveric training, whether or not it's using a virtual reality headset, which I think is very high fidelity, or whether it's using traditional screen-based two-dimensional models of education as well. This is something that will become much more prolific in the next few years. And the last use case I'll talk about is surgical and procedural training. This is the one that a lot of people really want to hear about because it makes sense. It makes sense to use virtual reality to do things with no risk of patient harm. It makes sense to do procedures and practice procedures in as high a fidelity environment as you possibly can without any risk to the patient. The whole see one, do one, teach one paradigm has really been kind of usurped by modern simulation education and high fidelity simulation. Nowadays, most people will never touch a patient before having done at least a few simulations for a high-risk procedure, be it a central line, be it a lumbar puncture, be it even just bog standard venipuncture. Now, this is taking it a step further, and this is talking about surgical training. This is talking about actually getting in there and having a virtual reality environment that simulates surgery with all of the very intricate, minuscule, minute details that surgery requires. And virtual reality is getting to a point nowadays where we are able to provide that. Now, this is a very nascent technology. Really, in the last 2 to 3 years has virtual reality been incorporated into some of these trainers. But there has been some investigational signal that has shown that surgeons may have an improved technical ability using virtual reality training compared to traditional training methods during their first few surgeries on a patient, meaning that there's a high potential that those first few patients are at lower risk of mistakes, of complications than they would have been otherwise when a surgeon is operating on them who has used virtual reality. One of the very interesting things within this domain of education is haptic feedback and how you're providing that, because so much of surgery and procedures in general relies on touch. It relies on feel. And one of the things that virtual reality is lacking in is feel, because there's nothing to push against. Everything is virtually generated and given to your eyes as a visual. There's no actual objects in the field. So what a lot of surgical simulators are doing is incorporating virtual reality, as you can see in the image here. In this case, the learner is using the laparoscopic instruments you see on the screen, and they are looking at the screen on the screen or within the headset, just as they would within an operating room. And in doing so, they're able to feel as if they are doing the laparoscopic surgery on the patient, and those laparoscopic instruments are able to provide very minute haptic feedback to the surgeon, and they're able to see the expected laparoscopic view on the screen within the simulated operating room. This whole thing just feels incredibly high fidelity, that the learner is immersed in whatever surgery that they are doing, just as they would be in a real operating room. One other aspect, one other process that could be trained within this type of environment is procedural checklists. One that has come up in the literature is training OR nurses to open scrub kit or open OR kits, so open different surgical trays or other things like that, and walk through the procedural checklist that they have. So within the virtual environment, within the operating room, in a virtual space, the nurses are able to actually open those kits and hand them to the scrub techs and practice doing that in a way that doesn't waste time, money, and place patients at risk of infection if it's done slightly incorrectly. So even for smaller things like that don't need that like strong haptic feedback, virtual reality is being used in this kind of surgical and procedural training domain. Just like in the other use cases that were described, this is able to provide immediate feedback to the learner. The computer is able to log exactly what the learner did, where they looked, how they interacted with the model itself, and provide feedback based upon that using pre-established checklists. It's also able to record everything that was done, so it can go back and be reviewed by a proctor, either one-on-one with the learner or in an asynchronous fashion. Unfortunately, a lot of surgical and procedural training now, due to the need for these type of haptic instruments and the incorporation of existing technologies that provide that haptic feedback, a lot of those do have to be in a sim center because they're expensive, they're clunky, they're large, they can't go home with the learner. So this may not have as much accessibility as, say, some of the virtual standardized patients. However, this does provide the learner with more accessibility to surgery than having to wait to do actual surgery. So if the learner has an afternoon free or a morning free or an evening free while they're on call, they can go to the sim center, put the headset on and practice and get more exposure to whatever type of surgery that they would like to practice. And of course, there are going to be a good number of limitations using virtual reality in simulated education. So the first that anyone trying to implement a type of virtual reality process into simulation education, the first limitation that they will see is that the laggards, the late adopters, will say that there is no evidence that says that virtual reality has shown any improvement in outcomes. There's never been shown any clinical impact of virtual reality in simulation education improving clinical outcomes. To which that is an entirely valid point. However, the evidence is still emerging at this point, and intuitively looking at this technology, it is hard to imagine that high fidelity immersive training does not improve outcomes, and it would seem to me that evidence would be coming forthwith once there is a little bit more adoption of this technology. Some of that resistance, it's been previously described that some of the resistance is a little bit potentially due towards a decreased technological literacy of some of the decision makers within a department. And the concept of see one, do one, teach one within medical education is just prolific. So if you watch a surgery, you do a surgery, and then you're good, you've now done it at least once and you can tell other people how to do it, that's pervasive. And the need for more expensive whiz-bang toys like virtual reality to provide that type of immersive experience before ever seeing a surgery. There's many within medicine who will question whether or not that is really the best way and the most cost-effective way to proceed. Another very real and kind of unfortunate aspect of virtual reality is cyber sickness. This is the buzzword for the motion sickness that you can occur during a dissociation between your surroundings and immersion within the virtual environment. This can be due to problems with the headset, either problems with the frame rate or a slight lag in the headset display. It can also just be very disorienting to be immersed within an external environment and can provide motion sickness. So certain learners may not have the ability to engage in virtual reality education just because they become very motion sick anytime that they engage in it. As mentioned a few times now, haptic feedback is something to really consider. If the objectives of your training require haptic feedback in order to be effective, you have to think long and hard about how you can incorporate virtual reality into that education. There currently exist quite a number of instruments, simulators that provide very good haptic feedback, and working with their manufacturers to get access to the video streams and the processing of the graphic data that comes from that simulation could potentially provide an opportunity for kind of future expansion to the virtual reality domain for that specific simulator. And then the other one's cost. It's not a free technology. It's relatively inexpensive as far as healthcare sim goes, but it does cost money. It is another system that will have to be maintained within a sim center. It will require some specialized training for the technologists to maintain and then teach the different learners how to use the technology. So there is an increased cost, both in human resources and dollars, in order to implement a virtual reality education program in your sim center. That said, that cost, when compared to the cost of many high fidelity mannequins, tends to be in virtual reality much lower than typical simulators, the cost of typical simulators that you'd see. All right, and now I just want to talk briefly about developing new scenarios and how virtual reality can be implemented within your sim center. As always, the most important thing that you can do in developing a scenario is to start with the objective and figure out what you're trying to do. Are you trying to develop a curriculum to teach emotional intelligence to interviewers? Are you trying to teach motivational interviewing? Are you trying to teach a procedure? Are you trying to simulate for learners the feel of a needle entering into the spinal canal during a lumbar puncture? Are you trying to simulate a laparoscopic cholecystectomy and performing all the different various parts of that surgery? Are you trying to simulate responding in an operating room, in a hospital room, in a preclinical environment, pre-hospital environment to a trauma? All of these different things that you're trying to simulate, what are you trying to get out of that? Are you trying to run checklists? Are you trying to drill procedures? Are you trying to teach how to actually perform physical procedures on a patient? Are you trying to run checklists and teach checklists? All of these different objectives are going to they're going to influence how you develop your scenario. And a lot of it comes down to what you're going to use for your user interface. Now, in traditional sim, you always have a model. You have either a simulated patient who is a model, and they've been trained to respond in certain ways to user input, meaning that the learner does something and the model is trained to respond in a certain way. Now, they're human, they're incredibly intelligent, and they're able to integrate and respond to unexpected situations. In other types of simulation, you have a mannequin that receives inputs. Say you're running a code. It receives inputs in the form of medications that are administered, or chest compressions, or intubation, or non-invasive ventilation, or shocks, or other things, defibrillation. The model receives that input from the learner and then outputs it in the form of oftentimes telemetry data or voice output or movement. In virtual reality scenarios, a little bit more thought has to go into how the model is receiving that input. In a lot of kind of physical scenarios where you might have a mannequin-based simulation, say the code again, you actually place the defibrillator pads on the mannequin. It's very definitive. That's what happens. And you can peel the pads apart and put them on a mannequin. You can turn the defibrillator on. It can detect the intrinsic rhythm within the mannequin, and you determine whether or not you need to shock it. In a simulated environment, if you're doing the same thing in order to maybe provide some at-home training for code scenarios, you would have to look into what would actually cause the model to know that it had pads placed on the mannequin. How would the user take out the pads? Would it be a hand recognition type software that would then require different hand gestures to interact differently with the computer model? Would it be a controller-based model where you would have to then use a specific controller in order to provide certain inputs? You would have to track different movements that the avatar of the user within the simulation would make in order to detect when they pick up the pads from the defibrillator. And then you would have to determine what series of inputs would be required in order to actually place those pads on the mannequin. How would you actually change the defibrillator? Would it be a menu with selections that would come up? Would you actually push the buttons with your finger on the defibrillator? All of these considerations go into what it would take in order to make a virtual reality simulation. Once you have those inputs, and those inputs can be anything. It could just be motion of your body with natural language processing and certain speech to text technology that we have now. They could be voice activated. The person running the code could simply say, "You please go get this," and they would get it. You could say, "Please administer the epinephrine now." All these different forms of input are possible within virtual reality and just need to be considered. Like, it all depends on what the objective of the scenario is. Then it's extremely important to realize how the model is going to output data. Are you going to be generating telemetry? Are you asking the model to integrate the learner's inputs and provide a speech back and provide a conversation? Are you trying to provide haptic feedback? Say you're performing surgery and you want tissue to feel as if there's resistance as you're pushing through it. that's something that would have to be considered when designing the scenario. And I can't emphasize how important that haptic feedback point is. If you are doing a scenario that requires that, giving a long thought towards how you're going to provide that haptic feedback, because there's nothing that pulls people out of virtual reality more, out of that immersion from virtual reality, more than not having some type of haptic feedback. Sometimes it can just be vibration of a controller that they're holding, and as the controller vibrates, it feels as if there's more resistance, and that's enough. Sometimes, especially when you're doing surgical procedures, the minute movements are so fine that haptic feedback needs to be a little bit more refined than just typical vibration. And then once you've determined how the user and their avatar within the simulation itself is going to interact with the model that you have, it's important to realize how you're going to display that to the user and enable that type of interaction. And that gets down to 3D modeling. We can go into extreme detail about 3D modeling and the different technologies that can enable that. Suffice it to say that there are wide libraries of 3D models out there. It would behoove anyone interested in this process to enlist the services of a graphic designer, a graphic artist, a 3D designer, in order to generate and develop the type of experience that they are trying to provide. But it's a relatively low intensity process to develop, depending how high fidelity you want to be with this. The different 3D models that would then be incorporated into the model and used to kind of facilitate that user model interaction that characterizes virtual reality training. And that's really it. Once you have your user interface, once you have an ability to meaningfully interact with the model, and you have the visual interface of the 3D model itself, then you are able to start enlisting beta testers and trying out and trying to run through the scenarios that you're trying to do. And you change the model that you have and change how the users interact with the model based upon that until you have an output that an eventual product that you think is worthwhile. It is much more specialized than traditional simulation education. You can't just grab a mannequin, put it on a bed, and then manipulate telemetry data like you would for a 3G or a trauma man or some type of traditional high fidelity mannequin in a sim center. It takes more, but the time investment that you have into making that type of software has these massive benefits that were talked about before: the accessibility, the repeatability, the ability to provide immediate feedback to the learner without the need for a technologist or a proctor around. Those are massive, and it provides this incredible access to simulation education that just is impossible to find in other domains of education. So that is a brief, I suppose at this point, 9-minute overview about how to develop new scenarios within virtual reality, within a simulated 3D environment. And I will just close with this graph again. The future of virtual reality, it seems like science fiction. It seems like this lofty goal that's always 3 years away. But we really have reached a point in the commercialization of virtual reality technology that enthusiasts are really being able to get in there and start tinkering with it. And historically, that is kind of the tipping off point for a lot of emerging technologies to move and allow the early adopters to generate enough meaningful product that individuals in any given community will start to utilize it. And that early majority will then popularize it enough that the remainder of a community will tend to jump on board. The benefits of virtual reality education, once some of those initial hurdles are overcome, they're really unquestionable. The ease of access, the automaticity, the lack of a need for personnel who are specialized in simulation education in order to provide that type of education, that is massive and will allow simulation education, this high fidelity simulation education, to get pushed out of major academic centers and into the community. It's a technology that has massive potential to revolutionize what simulation education is and how it's performed. So I hope that this talk was able to provide you with a little bit of background and a glimpse into the future of where, at least I think, simulation education will go, and some of the different means that we have at this time and in the near future to use it in order to provide a quality product. And then here I just provide a few different references, both just for general virtual reality and simulation education, as well as for virtual simulated patients, virtual anatomy education, and surgical and procedural training. I'm very excited about this technology, and I'm more than willing to talk to anyone else about it further. Please feel free to reach out to me on Sakai or at my personal email linked there. Thank you very much for listening.